I'm going to show you how to diagnose and fix this 4K Hisense TV that won't turn on. The number one and most common cause is a defective main board, and number two, less common, is a defective power supply. In order to properly diagnose this TV, we'll have to open it up and take a closer look inside. For those of you who don't know me, I'm Nick. I started Nick's TV Repair about a decade ago, and since then we've fixed over 27,000 devices. Now that we've removed the back cover, we have exposed our circuit boards. We can now do some voltage checks using our multimeter. Before we do that, we do want to disconnect everything from the power supply in order to make sure that the backlights or the main board don't offset any of our voltage readings. I'm going to disconnect the power connector from the main board and not the power supply, as well as our LED backlights. The reason for this is you always want to take a voltage measurement from the wired side, never from the exposed pin side. Otherwise, you're just shorting voltage lines together and damaging the TV further. And the first voltage reading I'm going to take is the 12-volt line. I'm going to unplug and plug the set back in. When it's first plugged in, you'll notice that it quickly jumped to 12 volts, and then now it's slowly decreasing down to about 10.2 volts. Also, to clarify, we are getting some weird numbers, but this is actually expected. This is a known good power supply, and we're gonna get a few other oddball numbers. Now, if you're not getting the same readings that I am, if you're getting no reading at all, then most likely that's because your power supply is defective and needs to be replaced. Next, let's take a voltage reading of our standby line, and we're not getting any voltages. Let's take a look at our 18-volt line. We're getting just about 14 volts, 13.99. Let's take a look at the BSW, and that's about 0 volts. And then just next to it, we have our BRI line, and that is also about 0 volts. At this moment, we're getting lower than expected voltage readings and missing voltage readings. The reason for this is because the power supply doesn't actually turn on its own. It needs the main board to tell it to fully turn on. Because we have it disconnected, it cannot actually fully power on. So let's bring the power supply to our workbench and trick it into fully turning on. Now, in order to trick this power supply into fully turning on, we do need to inject 3 volts into the BSW line, the BRI line, which is going to be the backlights, and then finally the standby line. In order to do that, I'm going to be using this little battery pack that has 2 AAA batteries in series, so that's going to provide us with the 3 volts. If we zoom in on the legend, we'll see that we have BSW and BRI that are going to be the top right, and then we have our standby, which is the third from the bottom left, and that's going to be on this connector here. Let's flip the board over. With the way I flipped the board over, the BSW and the BRI are now at the bottom right, and the standby line is the third from the top left. I'm first going to solder down my ground pin, then the BSW and BRI lines, and finally my standby. Now, the standby line, if we follow it, goes to this jumper over here, and I just find it a little safer to solder over here. It's a little less crowded. Perfect. So now when I flip the switch to the on position, the power supply should fully turn on. All right, so we'll go ahead and plug in the unit. I've installed the wire connector so I can safely take my voltage measurements. So my switch is off right now. We're still getting 10 volts. Let's go ahead and turn it on. And look at that, we now have our 12 volts. Let's look at our standby voltage. Obviously it's gonna be present since we're injecting it. Let's take a look at the 18 volts. So that was at 14 earlier, and now it's at 16.5, which that's actually the expected output voltage, 16.5. And finally the BSW, of course, also expecting the 3 volts since we're injecting that voltage in, and the BRI, which also 2.8. So we'll disconnect the power supply and bring it to our TV for a final live test. Our power supply is back in the system. We have our switch installed. We don't have the main board connected to the power supply, but we do have our LEDs connected. We now have power to the TV. Let me flip the switch, and what I'm gonna look for is our LEDs. Do I get my LEDs shining through the chassis? And sure enough, I do. I'm gonna flip the switch in 3, 2, 1, and you can see we have our LED lights bleeding through. Turn it off, on, off, on. So you can see it's turning on and off on my command. Now, because our backlights are turning on, I do want to do a quick voltage measurement on our output voltage here for the backlight. We're getting 137 volts from the white wire, and let's take a look. 136.6 on the black wire. Now, because we're able to get the 12 volts from the 12-volt line and our 16.5 volts from the 18-volt line by introducing the 3 volts to the standby, BSW, and BRI lines, that does to me confirm that our power supply is working properly. We also, of course, are getting our our backlight power and the backlights to turn on. By process of elimination, this means that the mainboard is the cause of our fault and the reason why the TV won't turn on. If you have a defective mainboard you'd like to send in for us to fix, we do offer flat rate services which come with a 1-year warranty. We have those available on our website, which I'll link in the description down below. If you're interested in finding out exactly how we fix these mainboards, keep watching. We're about to cover that. For the mainboard removal, we're going to start by disconnecting our connectors. For the ribbon, we have a latch mechanism. We have to lift up the black latch, then we can wiggle out the ribbon. We'll remove our speakers, IR, and button. Here we have another latch mechanism, so we're going to flip it up, and then we can wiggle it out. Next, we'll remove the shroud. There is a latch on both sides, so using my nails, I'm going to flip those away. And finally, we'll remove the 4 screws. When these mainboards fail, they typically fail due to a software malfunction. The software is located on the EMMC chip, which itself is located underneath this heatsink. So let's remove the heatsink and take a closer look at that chip. I have 2 plastic pins holding in the heatsink. To remove it, I'll need to pinch them and push them through. And here is our EMMC chip. As you'll notice, there are no pins around it, and that's because it's a BGA type chip. BGA, which stands for ball grid array, is the way that it connects to the PCB. So it just sits on a ball grid array. In order for us to check on the functionality of the chip, we will need to remove it using our BGA rework machine. What it will do is heat up the PCB from the bottom and the chip from the top simultaneously until we reach the solder's melting point. Then we'll be able to remove that chip, put it in our programmer, and check on its life. Because I have high confidence we're going to find out the EMMC is defective, we will preemptively program a new one using our XGECU T56 programmer. To do this, we're opening up the directory to select the 4 ROM files to program to the EMMC. ROM files are different types of software used by the TV. One of these ROM files, for example, will contain user data, another might contain the operating system, and another could contain the data for the screen so the mainboard can properly display a picture. Now we can start the programming. This process can take some time, so while we wait, let's start the removal process of the original chip. As mentioned previously, we are going to use the rework machine, which will simultaneously heat up the PCB from the bottom and the EMMC chip from the top. It takes about 7 minutes for the machine to reach the solder's melting point, at which time we can go ahead and remove the EMMC. We're going to use the Easy JTAG programmer to check the life of the component, as the T56 does not have that feature. And as you can see, the system is throwing an error stating that the health of the component is bad. And if we check more closely, the SLC single level cells state that they are in good health, but the MLC multi-level cells have exceeded the maximum estimated device lifetime. Now that we've confirmed the original EMMC chip is defective, let's go ahead and prepare the board for the replacement chip. We are clearing up all of the original solder using our desolder braid. And we'll do a quick cleanup with isopropyl alcohol to get rid of the spent flux. Now we can add fresh flux and line up our replacement chip. And now the machine will take about 7 minutes to complete the reattachment process. Now that we finished installing the replacement EMMC, we can go ahead and install our heatsink. And I actually haven't done it yet because I'm realizing that the original thermal paste is very crusty, so we're actually going to want to replace this one. I'm going to use a little bit of isopropyl alcohol and a Q-tip to loosen it up, and then a Kimtech wipe to get the rest. I still have a little bit, so we'll just do a final cleanup with a new Q-tip. And so we also have the heatsink thermal paste. So for this one, I'm actually going to use this spatula type tool to get the majority of it off, and we'll get the rest with the Q-tip. And these processors don't get too hot, so it's not necessary to go with super high-end thermal paste. The ceramic 2, which is pretty much the equivalent of what was on there originally, will be good enough. Just spread that around a little bit manually. And before we fully lock it in, I just want to put a little pressure with the heatsink. Make sure we have an even spread. And it looks like I have a little bit here on the edge missing. All right, that's better. Now we can lock it in and bring the mainboard back for a final life test in the TV. I've installed the mainboard back into the TV. Let's power it up and see what we get. And we do have power. The TV just turned on. We have the Hisense logo. Let's wait for it to boot all the way in. Okay, and it looks like we do have full functionality. That does complete our repairs. If you have a mainboard you'd like to send in for us to fix, we offer the flat rate services, which come with a 1-year warranty, and I'll have links for that in the description below. If you found the video helpful or useful, leave us a like, subscribe for more content, and thank you for watching.